Hi friends, welcome to my YouTube channel. Hope you all are doing good. In this video, we are going to discuss about the fiber reinforced concrete. So coming to the introduction part, the plain concrete possesses a low tensile strength, limited ductility and little resistance to cracking. Due to the poor tensile strength, micro cracks are developed in concrete. So in order to reduce these problems in plain concrete, small closely spaced randomly oriented fibers are introduced which will reduce the micro cracks and improve the static and dynamic properties of concrete. So we know the concrete is poor in tension and also it has a very less cracking resistance. So we are just increasing the ductility and resistance to the tension by introducing the small sized, closely spaced and randomly oriented fibers into the concrete such that the tensile strength, the ductility and also the crack resistance problems are dealt with. Okay, so we'll discuss the factors that affect the properties of fiber reinforced concrete. Types of fibers, that is if we are going for various material types like glass, steel, etc. Volume of fibers, if it is in low volume or high volume or moderate volume. Aspect ratio, orientation, in which direction it is oriented. That's perpendicular to the application of load and parallel to the direction of application of load. We'll see the role of fiber size and workability. Okay, now let us first see types of fibers we have. So we'll just deal with one after one. Okay, coming to the first one, types of fibers. We have glass fibers, steel fibers, polypropylene fibers, nylon fibers, asbestos fibers and carbon fibers. So these are the types of fibers depending upon the material. Coming to the volume. So classification according to the volume fraction. Low volume fraction, that is less than 1%. Okay, 1% of the cementitious material we are considering. Moderate volume fraction, that is between 1 to 2%. High volume fraction, that is greater than 2%. So let us first discuss individually what is low volume fraction, medium volume fraction and high volume fraction. So the fibers are used to reduce shrinkage, cracking. These fibers are used in slabs and pavements that have large exposed surface leading to high shrinkage cracks. Dispersed fibers offer various advantages of steel bars and wire mesh to reduce shrinkage cracks. That is, whenever we are using fibers, they are dispersed in nature, whereas steel bars are oriented as per our design. We are just aligning them in that position. But fibers, they are randomly oriented. The fibers are uniformly distributed in 3 dimensions, making an efficient load distribution. The fibers are less sensitive to corrosion than the reinforcing steel bars. The fibers can reduce the labor cost of placing the bars and wire mesh. Moderate volume fraction. The presence of fibers at this volume fraction on increase the modulus of rupture, fracture toughness and impact resistance. So at this moderate volume fraction, we are increasing the modulus of rupture, fracture toughness and impact resistance. These composites are used in construction methods such as shotcrete and in structures that require energy absorption capability, improved capacity against delamination, spalling and fatigue. That is splitting of concrete into layers. The layers of concrete will just wear off. Okay. Next, high volume fraction. The fibers used at this level lead to strain hardening of the composites. Because of this improved behavior, these composites are often referred as high performance fiber reinforced composites, that is HPFRC. So in the last decade, even better composite fibers were developed and are referred as ultra high performance fiber reinforced concrete. So this is the centerline deflection we are showing as per the load. So we are seeing the centerline deflection with the application of load, with the increments of load. Okay, and see, whenever we are not having any fibers in the concrete, this is how the mechanism of the flexure, the toughness of concrete will be there. But when we are adding the fibers, we can see it is not breaking totally, it's breaking in a pattern. That is, it is showing the mechanism of increasing flexure toughness of concrete. So it is increasing the flexure, that is bending capacity, toughness, okay, of the concrete with fibers. So this is how it will be. Whenever we are not adding any fibers, it is breaking out suddenly. But here we can see there is a pattern following. Next, coming to the role of fiber size. To bridge the large number of micro cracks in the composite under load and to avoid large strain localization, it is necessary to have a large number of short fibers. So the uniform distribution of short fibers can increase the strength and ductility of the composite. See, whenever we are going for a design, we have to select the fibers, but there arises the case of choosing the volume fraction of long fibers in small number or the volume fraction of short fibers in large number. So let's see which one is preferable. The long fibers are needed to bridge discrete macro cracks at higher loads. However, the volume fraction of long fibers can be much smaller than the volume fraction of short fibers. That is, whenever we are choosing the long fibers, the volume is reduced. As already they are long in nature, we don't have to choose them in more number. But when we are going for the short fibers, we have to take them more in number. Thus the volume fraction is more. The presence of long fibers significantly reduces the workability of the mix. Okay, coming to the aspect ratio. The another important factor that influences the properties and behavior of fiber reinforced concrete is aspect ratio of the fiber. Generally, aspect ratio up to 75 is considered. Increase in aspect ratio increases the ultimate strength linearly. Okay, beyond 75, the relative strength and toughness is reduced. So up to that point, that is up to the ultimate strength, it is increasing, but after that point it is again reduced. Okay, next, orientation of fiber. I told you it is in which direction. If it is in the direction to the parallel load, in a parallel one or a perpendicular one. Okay, one of the difference between the conventional concrete and the fiber reinforced concrete is in conventional concrete reinforcement are aligned or oriented in desired direction, while the fibers are randomly oriented. Whenever we are designing a beam, we will discuss this. Okay, we'll discuss about this longitudinal fibers, tension fibers, and all the stirrups. But in this, we are designing the reinforcement along with the direction of the orientation. That is, orientation. That is, if the load is applied in this, we are saying this perpendicular to the direction of applied load. Okay, but here they are randomly oriented. We are not going to align it in particular direction. We'll just mix it in the mortar and it will be randomly oriented. So as the test done fiber reinforced concrete specimens, it was observed that fibers aligned parallel to the applied load offered more tensile strength and toughness than randomly oriented or perpendicular direction. See, whenever we are applying the load in this direction, so whatever the fibers that are aligned in the direction parallel, see, whenever the bars are in this direction, that is parallel to the direction of application of load, they are offering more resistance to toughness. The flexural capacity is more and more tensile strength is there compared to the perpendicular one. Okay, perpendicular is in this direction, parallel is in this direction. Okay, whenever we are talking about a member subjected to the vertical loading. Even in the orientation of fibers, we have these fiber orientations. See, continuous and aligned fibers. These are continuous. There is no breakage is there in between, and aligned. They are in one single direction. But coming to discontinued and aligned fibers, these are discontinued, but they are aligned in one particular direction. But here we can see they are discontinuous and also randomly oriented. Okay. So this is the last important topic of this video, that is applications of FRC. Where is this fiber reinforced concrete used practically? Runways of aeroplanes at airports, road pavements, industrial floorings, bridge decks, canal lining, refractory lining, blast resistive structures, precast products, prefabricated formwork molds, and small beams. Okay. So that is it for this video, guys. If you like this video, please like, share and comment to the channel, and don't forget to subscribe to my channel. Your subscription would greatly help me. I appreciate you watching this video. Thank you.